All right, we're on week 6, set 3, SWYK 2. As I said before, there's always a review question that I have to throw in there. I have to throw in at least one from the current textbook if I want to choose problems from a different textbook. Okay, so this one is sliding down 9. Where is that? Oh, there it is, sliding down 9, right? So 0, -9, find your dot, and then draw your picture using your 1A, 3A, 5A. All right, that'll nice trip down memory lane. I'm going to use, instead of using a graphing calculator for this particular section, I'm going to use Desmos.com/calculator, which is an awesome tool to use. And in fact, I'm going to try to figure out if I can be allowed to use this website instead of a graphing calculator. But maybe not. I might have to show you all the cool things that a graphing calculator can do. So I've listed out the 4 different equations that are in this particular section. Let me see if I can slide this up just a touch. There we go. So the first one being y equals 7x squared or plus 12x minus 1. So you can see that if I grab 2 points on one particular axis, that you'll see them light up, and then the axis becomes light blue. And then if I move my fingers out, you'll see that I'm stretching just the x-axis. Only not the y-axis. Well, that kind of is helpful. Try not to claw me, kid. All right. What I would like to know is what these x-intercepts are. These things are important to me. And I'm going to try to freeze the screen here in a second to write on. Well, actually, I'll just use my annotate feature. That'll work. So over here on the left is negative infinity. Over here on the right is positive infinity. The y values in between these are negative y values. Okay, hopefully that makes sense. Negative y values. But up here, okay, so this section and this section have positive y values. Now, we know that so we need to know that kind of stuff. Plus, we need to know where these 2 points are. So I'm going to jump back over to my notes, see which graph makes sense, and I'll probably have to clear that off. We're looking for something that has negative 1.79 and positive 0.08 and opens up. That's what we're really looking for. Okay? And I think you can clearly see that it is choice A, right? Now, this particular section says we want to know where all the x's are that are positive or equal to 0. Positive or equal to 0. Well, that would be, according to what we had here, that would be 2 different sections. So we had all of these points in here up to and including negative 1.794. So one of my answers to this question is going to be negative infinity to negative 1.794. Now, why do I have to include the bracket? Because my inequality is equal to. If it had been greater than but not equal to, then I would not include that, and that would have been a parenthesis. But I got this other chunk over here starting at 0.08, and my face is in the way, possibly. Okay, we'll live with it. Now, how do I say I want both of those sections, both that section and that section? We use a term, a symbol that looks like that, and how do we read it? Especially if you're at a party, you want to know how to read that kind of stuff. Otherwise, they'll throw you out of the party. Union. That is the union. So, if I go back, let me close this, jump back over here. You can see the answer to the question, negative infinity to negative 1.79 union. Why? Ooh, I almost circled the wrong one. Why did I almost circle the wrong one? What's different about those two? What's different about B and C? B does not include the endpoints. And because we had the equal to 0 part, the equal to caused me to need those brackets. If it was not equal to, then I would not. Ooh, did I go past? Oh no, I did a good job. Okay, question 3. Now we're looking at a different graph. Let me jump back over here. Now we're talking about, let's get rid of that one, take this one. Now we're talking about a picture that looks like this. Now, where's it hitting the x-axis? It is hitting it at 0.429. 0.429. So we're looking for something that looks like it's hitting at 0.429. And so that's going to be, is that letter A again? It is letter A. Hold on for station identification. Okay, now you can see that we want to know when is it less than 0. So that means it has to be below the x-axis. So let me go back and look at my picture on Desmos. None of that looks like it's below the x-axis. I mean, you can zoom in as far as you want to. You're never crossing the x-axis. So how can you find any points that are below the x-axis? You can't. That's the whole point. The whole point, nothing but the point. Therefore, whoa, that's not what I wanted. Therefore, there's no solution to this question. Now, what if that had been flipped around? What if it had been greater than 0? Then, actually, that's not listed. The one for greater than or equal to 0 would have been listed right there. Everything was greater than or equal to 0. But that's not what they asked me for. They asked me for less than 0. And there wasn't anything that qualified for that. Okay, so here's another one. This time we want greater than or equal to 0. And we come to our picture, right? We're going to it says without a calculator, but at the moment, because we're not going to include some things that we will include next week in terms of other things, we're just going to graph it. So here we have our graph, right? And we could do the opposite of b over 2a, all that good stuff, and that would have worked. Looks like we end up having 3, 4. We could have done opposite b over 2a. But in graphing it, do you see how everything is above the x-axis? So when they asked me for everything that's greater than or equal to 0, isn't that the entire thing? So all real numbers fit that category? Now, what if they had flipped it around and said less than 0? Well, that would have been a no solution situation. But since it never crossed the x-axis, we didn't have anything above it. We had everything above and nothing below. Okay, next question. Solve the problem without using a calculator. Now, I do see this, and I want you to realize that the first thing I would do in order to graph this is I would flip this around. X squared minus 9 is less than 0. Okay, and so when we do that, oops, let's get rid of that. Let's go here and get rid of that. We end up with this, okay? And you can see that we have x values at -3 and +3. Very nice. They wanted to know when it was less than 0. So if you're looking at the picture, right, and we know it's crossing at 3 and -3, it's doing this kind of thing, right? Where is it less than 0? Well, it's less than 0 in the middle. So that's this section right here. Well, if this is 3 and this is -3, it does not say equal to. So this is the wrong answer. Even though it's close, it's the wrong answer. I want everything from -3 to 3, but not including the endpoints because that's where it's actually equal to 0. I have to be less than 0. Now, what we're finding, these solutions to this situation are defining negative intervals or positive intervals. This is a negative interval, okay? Back up here. Let's look up here. This was a better scenario. What we were finding when we were solving these things, now it did have the equal to part. So technically, the positive interval here would have been from -infinity to -1.79 parenthesis union 0.08 to infinity. So technically the answer to our question included 0 in that particular part. But if I was just asking you for a positive interval, it would not include the boundaries, because it was just what's above the x-axis, what's below the x-axis, that kind of thing. And just like the last example. Now, some of these that are all solutions or no solutions, obviously you can't, you're all positive or all negative or whatever. In this case, you can see that that's negative. Now, could you, I know we're going over a little on this, could you identify positive intervals for this last one? Sure, we could. We could do positive intervals. Everything from negative infinity up to -3. Those are all positive y values. That whole section right there is positive. And then we have another section here, 3 to infinity, right? Everything from 3 to infinity would be positive y values. So you understand the terms negative y values and positive y values. Okay, that's it for this week. Now you're ready for your test.